Now let's see these properties of a bounded lattice. So what is a bounded lattice? There is upper bound and lower bound. What is the upper bound? Every element is related to that item, that element, that particular element, right? And what is the lower bound? It is related to every other element, right? So in order to understand these properties, you have to understand some basic rule first. So the rule is this. I'll just take an example and I'll explain you. Let us say D18 and then divides. So D18 is going to contain 1, 2, 3, 6, 9 and 18 here, right? So now if you observe this, 2 and 6 are related directly. There is a relation 2, 6, right? So whenever two elements are related, when you try to find out the greatest lower bound, then it will be one of it, and if you try to find out the lowest upper bound, then it will be 6. Are you getting this? Since these two are directly related, the greatest lower bound is going to be 2 and the greatest least upper bound is going to be 6. You have to remember this always, right? So what about these two? Even these two are also related, right? What about these two? These two are also related, but then 6 and 9 are no way related. In this sense, 6 is not going to divide 9 or 9 is not dividing 6. Therefore, you don't have any item like 6 9 or 9 6. You don't have any such ordered pair. That is why, this particular rule doesn't apply there. So if two elements are related in any poset or a lattice, it need not be lattice, it can even be poset also. So in a poset or a lattice, if two elements are related, if you have two elements like this, they are present in an ordered pair, then definitely the least upper bound is going to be this and the greatest lower bound is going to be this. Remember that always. Now let's come back to this. Now in a bounded lattice, LUB, least upper bound of A and I. Okay, so first of all, here I am using the terminology, one is I and other is O. So I is nothing but the upper bound of the lattice, okay, and O is nothing but the lower bound of the lattice. So I is the upper bound and O is the lower bound, okay. Now see this, least upper bound of A and I. So A is some element present in the lattice and now I is the upper bound. So when can we say that an element is upper bound? An element will be upper bound only when every other element is related to it, isn't it? Which means A should be related to this. Definitely, if I is the upper bound, there will be an element or an ordered pair present in the relation of type A comma I. Since A comma I is present, now we can easily guess what is the least upper bound and greatest lower bound of this set. Least upper bound of A comma I is going to be A. Oh sorry, it is the greatest lower bound. Yes, least upper bound of A comma I is going to be I and the greatest lower bound of A comma I is going to be A, which means it is the greatest lower bound, okay, greatest lower bound, and it is the least upper bound. So here also this is going to be the greatest lower bound and it is going to be the least upper bound, okay. And now look at this one. Now when you have this ordered pair A comma I, what is going to be the greatest lower bound? Greatest lower bound of A and I is going to be A. Got it? Okay. And now let's talk about the lower bound O. So when is an item going to be lower bound? Whenever it is related to every other element. Therefore, if O is the lower bound of a lattice, then every other element, it will be related to every other element like this. So for any element A, right, which is present in the lattice, the lower bound O will be related to it. Therefore, such a kind of order pair you can definitely see. So what is going to be the least upper bound and greatest lower bound? In this case, it is going to be least upper bound and it is going to be the greatest lower bound. So see this, least upper bound of A and O is going to be A and greatest lower bound of A and O is going to be O. So how did I do this? You have to understand this property. So whenever two elements are related, which means if there is an ordered pair A comma B present in a poset or in a lattice, then definitely the greatest lower bound is going to be A and the least upper bound is going to be B. Now using that property I am solving these questions, right? So you need not by heart these properties, they are just intuitive. So how did I solve it? Since I am calling I as the upper bound, every element is related to I. Therefore you will see the ordered pairs of type A comma I, and since O is the lower bound, O is related to every other element, therefore you see ordered pairs of type O comma A. And since this is an ordered pair present, the first element is going to be greatest lower bound and the second element is going to be least upper bound. The same thing happens here as well, right? So don't by heart it, it is simply intuitive. Just remember this rule. If you have A comma B, this one, right? In a poset or lattice, this rule is always obeyed, and from that you can derive this. Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.